Well, as you saw in the video, the inside of the cell is more negative and the outside is more positive, so it's because of the distribution of ions. So potassium ions, they're higher on the inside of the cell, and I believe that this is on your study guide. Sodium ions, there's a more or a higher concentration on the outside of the cell. And so what happens is that potassium leaves. So the symbol for potassium is K+. Potassium always wants to leave the cell because there's so much more on the inside of the cell. And sodium wants to leave, wants to enter the cell. Okay, but so if this kept on happening, well then there would be no more potassium left on the inside, there would be no more sodium left on the inside. So to get them back to their normal concentration gradient, there is this active transport pump called the sodium-potassium pump. So this then sends the ions the opposite way. Yeah, so if you remember, active transport against the concentration gradients. Okay, so then the ion channels are moving these ions. So yeah, once again, the inside of the cell is more negative, so it's called the resting membrane potential. Resting membrane potential meaning that the neuron is not doing anything, it's just kind of sitting there, not doing any action potentials. But yeah, so it's the sodium-potassium ions moving that create this concentration gradients. Okay, and so again, the important thing is inside of the cell is more negative compared to the outside. And so the inside of the cell is about -70. You don't have to memorize this number as long as you know that it's negative on the inside. Okay, so now we're going to draw some pictures to show what is happening with the action potential. Okay, so pretend that this is a neuron. Let's put another neuron here. Okay, so I'm going to make the next neuron larger. It's not like there's a size difference, but I'm just doing this just to show you what's happening in this presynaptic neuron. Okay, doesn't look like the best neuron, but okay, and then this is supposed to be the axon. Alright, so on the dendrites and the cell body are these ion channels. So that's what those lines are supposed to be. Okay, so what can happen is, so let me write down. These neurons at the beginning, those are the presynaptic neurons. And this one is the postsynaptic neuron. Okay, so here, presynaptic neurons, they release their neurotransmitters, and these neurotransmitters are getting released because of an action potential that occurs in these presynaptic neurons. This time we're going to see the same thing happen in the postsynaptic. So those neurotransmitters come in, they're going to attach to the ion channels, and so then these ion channels are going to open. Now, if the channels that open are the sodium channels, we're going to bring in a lot of sodium here. And of course, there are many of these ion channels. I've just made 3. Yeah, and so what can happen is it can be 2 presynaptic neurons, or it could be 1 presynaptic neuron releasing neurotransmitters. Okay, but now we have a lot of sodium on the inside. Well, what charge does sodium have? It has a positive charge. So now we brought a lot of positive charges into the cell because of these ion channels opening. Okay, but if you remember, the charge on the inside of the cell was negative. Well, now it has become more positive. Now, if enough positive charges have come in, then these positive charges go to these channels on the axon. So the beginning part of the axon was called the axon hillock. So this is where we're seeing the first channels, but there are many channels down the line. Okay, so then these positive charges are going to open up these channels on the axon. These channels are called the voltage gated channels. And the ones that first open are the sodium channels. Okay, so again, it's only the positive charges that open these voltage gated channels. And then what ends up happening is that more sodium ends up coming in. So then these positive charges that came in when that first channel opened, it's then going to open up the next channel. And then you just get more sodiums, which then opens up the next channel. So I like thinking of this as kind of like a dominoes falling. If you can make the first channel open, if you can make the first one fall, then the other ones are going to follow. So then these channels are down the length of the axon. Okay, so only the voltage gated channels are on the axon. The ones on the dendrites and the cell body, those channels are called the ligand gated channels. And the ligand refers to the neurotransmitter, meaning that a neurotransmitter has to be there to open those channels. But the ones on the axon, those are the voltage gated channels. But yeah, so all it is that if you open these channels one after another down the length of the axon, this is called an action potential. So I'm going to write down here, this is when voltage gated channels open. On the axon. Okay, when the ligand gated channels open, this is called graded potentials. And so graded potentials, when these channels open and the ions come in. So in this case, the graded potentials that came in were the positive charges. And so only if positive charges come in, then that can open the voltage gated channels. Otherwise, those voltage gated channels cannot open. Okay, so now one more thing with this. So when you make the inside more positive, this is called depolarization. Depolarization is the parts in the action potential. But do you want it to stay positive like that forever? No. So now we have to get it back to negative, back to normal, once the neuron has done the action potential. To get it back to normal, so now we're going to open up potassium channels. Now when these potassium channels open, and these are also voltage gated, so they're opening when the inside has become too positive. Voltage gated potassium channels open. Now when the potassium comes out, it takes the positive charges from the inside of the cell to the outside. Okay, now the potassiums come out, and getting it back to negative, back to normal, this is called repolarization. Okay, so then the action potential goes down to the synaptic knobs, and then the action potential causes the neurotransmitter release from this neuron. Okay, so this is what happens for an action potential to be produced. Now let's look to see what happens if instead negative charges came in at the beginning. Okay, so again here, I'm going to make some neurons. We'll make this one larger again. We have the channels. Neurotransmitters are being released. So here, the neurotransmitter might be serotonin, GABA. These types of neurotransmitters open negatively charged ions instead. So here, the neurotransmitter goes and attaches to the ion channel, but instead of opening sodium channels, this opens chlorine channels. Well, now you're bringing a lot of negative charges to the inside. The inside was negative already. If it becomes more negative on the inside, those voltage gated channels do not open. And if those voltage gated channels do not open, no positive charges come in, well then an action potential will not occur. Okay, so only if the inside becomes positive.